Okay, everybody. Hello, hello, hello. For the very, very last time, hello to everybody out there in internet land. Am I coming in loud and clear? Can you hear me out there? Let me know in the chat. Hello, hello. All right. So it's very, very sad today, but it's my very last tutorial for this term. And look, it's very sad, but let's make the best of it. Let's enjoy it. And yeah, the puppy's in the background having a sleep. Um, yeah, we'll enjoy it. And let's do some questions, okay? Now, a few people have asked me about the final exam, so maybe if you have any questions, feel free to just jump in on the microphone or put them in the chat, or you can wait till the end as well. Whatever's comfortable for you, okay? So let's have a look at some questions. I thought today we could talk about mostly uh, questions involving the logarithm function. Okay, and last on Monday I did a lot of questions involving chapter 8, and I thought let's do some problems from chapter 9, because if we don't do them now, then there's no opportunity to do them at all. Okay, so I think these are some interesting questions here. So I thought we could do question 1 and maybe a couple of the integration questions, and then we can talk about matrices for a little while. Okay, but of course, as usual, let me know what's going on in the chat, or just jump in and let me know what you are thinking. So I thought we could talk about the question 1. Question 1's a nice question because it kind of reminds you about the definition of the natural logarithm, a little bit of calculus, and then proving a nice relationship that we all know, and rigorously proving it. Okay, so I thought we could start with that one and just let me know how things go. So let me just make a few more people presenters, because there's a few people who are joining us a bit late. Oops. Oh, Rudan, I just made you a moderator. Hang on. There we go. All right. So let's go to my document camera, and we'll work it out. All right. So the first part of this question, this is I'm using a new pen today, so let me know if it's hard to read, or if it's easy for you to read, or what's going on. All right, so the first question is, what is the definition of the natural logarithm? So this is just something that we define by an integral. I might just turn that light off. There we go. Okay, so that's the definition that we use. Okay, and you can interpret that as the area under the graph of 1 on t. Okay, so there's a physical, geometric explanation to it as well. So that's really all they wanted for part A. So let's move on. That's just I mean, you don't need to remember this either, right? Because in the final exam, you have your notes available. It's an open book exam, right? Okay, so the next part is explain why the derivative of the natural logarithm is 1 on x for all x greater than 0. Okay, so let's pause for a second. If you were asked to explain this, why the derivative of log x equals 1 on x. What are some ideas that you might draw on? Yeah, Vrudant, you're down with the FTC. Yeah, you know me, right? So why don't we differentiate both sides of this, and then we can apply the FTC. All right, so differentiate both sides of star and apply the FTC, the fundamental theorem of calculus. So we get that. So it's differentiating an integral. And so the derivative and the integral sign disappear, and we just replace t with x. Okay. So it's pretty easy one to do, but when they say sort of explain, they really want something like this. Right? They want some words. Okay, and the third part of this question is show that the natural log of x times y equals the natural log of x plus the natural log of y. Now, this is obviously a very important and well-known identity for logarithms, right? But using this definition, we can actually prove it like rigorously. Okay, Vrudant, put on you've raised a doubt. Put on your microphone and let me know what's going on, buddy.
Yes, hello. Okay, so if we actually integrate 1 by t from 1 to x, wouldn't it be 1 upon x minus 1?
Yeah, but what happens when you differentiate 1?
Oh, right, yeah, okay.
Yeah, so that's why it doesn't actually matter what this is. It'll work for any constant.
Right,
You know,
yeah.
when you differentiate an integral.
Right, okay. Thank you.
Yeah, so it's a good question, but yeah, it doesn't like that's not going to affect it at all because you're differentiating it.
Yep.
Yeah. All right, so they give you a clue on how to start this question. They say differentiate this with respect to x. Okay, so and here x and y are all positive, right? Okay, so we're imagining y as a constant and we're differentiating with respect to x. Okay, so if we do that, we'll get y over xy, and the y's cancel, and we get 1 on x. Okay, now 1 on x is also the derivative of just log x. Okay. So now you've got two derivatives that are equal. So what do we know about the functions inside them? They differ by a constant. Okay. So you can say that these two, that function and that function, because they have the same derivative, must differ up to a constant. All right, so now the question is, this is starting to look like this. So the next question is, what is our constant c? Well, it'll turn out that it will be the natural logarithm of y. How do you do that? Well, if x equals 0, this will be, oh, sorry, not x equals 0 because it's not defined. X equals 1. This will become natural log of 1 times y. This will become log of 1, which is 0. Okay, that's 0. So what is C? C is the natural log of y. Okay. Okay, so what we can do, we can put that in there, and then we get this plus that. So we have exactly, let's call this I for identity. Yay! Brilliant. Well, Rudan, you don't know that y is a function of x, do you? So the chain rule really only works when you know that y is a function of x. Okay. So if I was doing this a slightly different way, I would sort of maybe use partial derivatives here, but they don't talk about those things in this course. You will see them next term though. Okay, you will see them next term. Okay, so I'll go back to this in a minute. Let me just have a look at the second part of this question. So we proved that, and then use the same technique to show that this and this. So this is the same idea, right? So in this case, C would be equal to negative natural log of y, and you know it's very similar. So I won't repeat that, okay? But I wanted to have a look at these integrals here in question 4. Okay, so let's have a look at some of these integrals. They're talking about integration of the natural log function here. So I'll do these ones, and then we can throw the floor open to different questions. So let's do A, B, and C. Okay, let's start with those and see how we go. Okay. All right. So let me know, is that font or is it easy to read on the screen, or do I need a thicker pen? Let me know, because I just bought some new pens, and they're a bit thinner than my normal pen. What do you think at home? It's fine. Okay. I know sometimes people are watching on their mobile phones, and the screen is pretty small. All right, so let's move on. I'll choose a different color, just like a dark purple. Okay, so let's have a look at question 4. Okay, so let's consider e to the 2x over 1 plus e to the 2x dx. Okay, so the question is, what kind of strategy might we use for an integral like that? Okay, so that is the question. It's not possible to integrate it straight away, I don't think. Differentiate the bottom first. Okay, so if you okay, that's interesting. William, jump on the microphone, man. I want to hear what you've got to say. Tell us what's going through your mind, because I didn't think of that. So tell us what you're thinking. Jump on the microphone, buddy. William? No, can't hear you yet. Come on, I think you've got some interesting things to say here. We definitely want to hear you. If you press the little gear button in the bottom right-hand corner, you can test. Hmm. Hmm. Hang on, let me just have a look. Yeah, it's a bit weird. I'm not really sure what's going on.
Wait, can you hear me now?
Oh yeah, coming in loud
Yeah,
and clear.
my
What was the
mic
problem?
my mic was set to like a different thing that I had plugged in, not my actual mic.
Oh, okay. Are you
Um,
listening to music? Come
no,
on,
no,
William.
my PlayStation controller's plugged in. Like I just leave it plugged in, but that's what it
Yeah,
defaults
yeah.
to instead of my headset.
Yep, got it.
Um,
So what's your strategy, boss? Tell
so
us about it.
like if you differentiate lnx, like the answers or like ln and then like a function like ln fx, I guess it
Yep,
becomes like f dash x over
yep,
fx, right?
yep,
So then if you like integrating is obviously the reverse of differentiation, and like the bottom of the sum, like the denominator, is really similar to the numerator, but there's going to be and especially with e to the x, when you differentiate, it's going to have a similar answer. So you just want to
yep,
find that difference. So like if you differentiate the denominator, it just gives you 2 e to the 2x,
yep,
and then that is like 2 times the numerator.
yep,
So you end up getting like which means you need only like half of it in your answer, or you need to divide it by 2 in your answer. So I think it becomes half of ln, like when you integrate it, half ln 1 plus e to the 2x plus c. Yeah. Is that right?
yep. So the general principle there is that, and this is your thing. If you have a form like this, it's the natural logarithm of f of x. Yeah,
Yeah. Yeah.
yeah, and that's a very handy thing to know, right? Very handy thing to know.
Yeah.
Yeah. So yeah, you just need to be careful with the absolute value signs. Now, do we need to worry about the absolute value signs in there for this particular example?
Oh, it's gonna always be positive.
Yeah.
So you
So
don't.
so that's fine. But in general, you really should
Okay.
worry about this. Yeah. But that's great, mate. Thank you so much. So I actually did it a different way, but I think your way is much better. Okay. So let's have a look at what about, okay, let's do part B. So let's go back here. So here we've got e to the 1 on x divided by x squared. So can anyone, either on the microphone or on the chat, let me know what is a strategy for this one? What would you be doing if you were given that one? What's a starting point or a strategy that you think would work? Any ideas? Part B, people. Part B. What do you think? Come on, it's the very, very last tutorial. It's my last class for the entire year. So don't leave me hanging here, people. Don't leave me hanging. There's 10 people here. Come on. What is a potential strategy for this one? Any ideas? Alan, that's okay, buddy. I'm pleased that you made the last tutorial. Well, let me break it down, see if we can, so here it is, right? Let's see if we can. Yeah, Vrudan, I think you're on the right track there, buddy, because if we write it like this, you can see the derivative of 1 on x is almost that, okay? So what you can do is you can go, oh. Okay, so now the, that and that have a derivative relationship. So I would let that be your u function. So I think you're right, Brudan. I think that's one potential strategy. Okay, so we'll replace that and that with du. And 1 on x will be replaced with u. So this is an easy integral now. And back substitute to get the correct final answer. Okay. So that was our substitution. All right, so any questions for that one? You can see here, this one was pretty quick. This one needed a little bit more work. Okay, I mean, some of these questions you can just write down the answer a lot of the time as well. All right, so let's do one more question, peeps, and then I'm going to throw it up to open to discussion. Okay, so I thought question C would be a good one to finish on. Okay, so the integral of 3 to the x. So let's go and have a look at that. Okay, it's the very, very last one, and then we're going to do some discussion. Okay, so this is our integral. Now note that it's not 3 to the x plus c. Okay, a lot of people think that because e to the x is its own integral, then 3 to the x must also be its own integral, but it's not true. Okay, so one strategy here is to write this in terms of this is not a definite integral, Frudat. This is an indefinite integral, so you have a constant of integration. But let me know what you mean. Jump on the microphone if you want to talk a bit more.
Isn't there like a formula like we have for say integration of sine x or cos x? Like integration of a raised to x dx is equal to a raised to x upon ln a.
Yeah. That's true. That's true. So let's actually do that, and then we can, I mean, this is
Yeah,
the answer.
yeah,
But let's actually do it properly, and it's fine just to write this down, but let's do it with a little bit more care. So I'm going to write it like this, and then I'm going to write 3 to the x as e to the natural log of 3 to the x. Okay, and because exponential and logarithm are inverses, this is the same as this. Okay, so I can use the logarithm laws and bring the x to the front. And now we have our old friend, base e, x times a constant. So if I'm integrating that, it would be okay. And if you reverse these steps, you get back to 3 to the x. Okay, so this and this are the same. Okay. Okay. So, folks, I think that's enough of me talking. So, I want to hear from you. What questions do you have about maybe the final exam or other parts of the course, or what is it going to be like next term with your maths? So, what I might do is I might just kill the recording now, and then we can actually just have a conversation, and we can talk about anything you want to talk about. All right. So let me kill that, and we can have a chat.